Wow, it's a pleasure and honor to be here. So just to give you a little context about this glass of wine, it sprung up from a dinner conversation where I said that some of my best ideas actually came about when I'm a little bit tipsy. I'm a little bit, So cheers to creativity. Okay. So with that, I'm going to tell you a little bit about data science in the industry. Okay, and we're going to go from data to disruption. And so actually, the clicker is actually here. Okay. And apologize, I'm out of business cards. So if you can always find my LinkedIn and Twitter in the lower right-hand corner. And this is the agenda I will follow. I will talk a little bit about a couple of examples of big data and what it can do for you, and a little bit about what data scientists actually do. And then we'll take a look at a bigger industry perspective and a little bit into the future. Okay? And okay, so let's begin with a couple of use cases. So first use case, you might have heard of this, okay, is from Target. So can you read what this says here? So Target was able to predict when young woman's going to be pregnant before their father even know about it. Okay? So the thing is that what kind of data are they using to make this prediction? The prediction is actually based on just very simple input data. These are basically transactional data, right? What product you buy, where you buy it, how much you buy, and your payment method and quantity and so on and so forth, right? So this is very basic information. And what they find was that the insight that they discovered was that if you actually, buying a lot of calcium, zinc, magnesium, and switching to unscented items, that's indicative of pregnancy, okay? And obviously, this is the insight that they find. You have to do something about it, right? So Target decided they're actually going to create a coupon book just for moms. And this a little, first is a little bit creepy, right? Because, they actually have coupon book timed to the specific stage of your pregnancy. And when you receive that coupon book, you say, how do you know all that? Okay? So it's a little creepy, but Target was very smart, right? They actually, created a coupon book, but just with a little bit more baby product in it than than a normal coupon book, right? So it's still coupon books for mom, but a cleverly designed coupon book, right? So the result is that they increase revenue, right, and over this few years. So the second example I want to tell you about is from Zest Finance. So Zest Finance is actually an online lending company. So not many of you probably heard of it. How many people have heard of Zest Finance? Okay, only a few people, right? Not many of you know. So they are a small online lender, okay? And so basically the data that they have is basically page after page after pages of online application, right? Loan application. And so that's the data that they have. But the insight that they find from those data is that, like, if you actually fill out the application form with only uppercase or only lowercase, you're more likely to default. Surprise? You believe it? Some of you shake your head, some of you nod your head, right? So they didn't believe it either, okay? But what they do is that they actually use it to augment their traditional underwriting model, okay? And so proper capitalization is just one of these data points, one of these insights that they find. They actually find thousands of these insights, right? Things that you wouldn't have thought to have anything to do with financial, your default probability at all. They were able to find thousands of these signals, but together they combine and become very, very strong predictors of default. Okay? So what they did is that they actually used these thousands of variables in the traditional underwriting model to augment it. And the result is that they actually reduced their default rate by 40% and increased their market share by 25%. Fairly significant. Okay? So these are a couple of examples I want to share with you about. So clearly, big data is very, very important. Now, but there's also a lot of big data myth, data science myth, okay? One of the biggest myths that I often heard is that, some people think that if you have a lot of data, you're going to have a lot of information, and you're going to get a lot of insights, and everything will be good. This is actually not quite true, okay? So data and information are not the same thing, okay? So let me just illustrate this with an example. You all have hard drives at home. That hard drive contains data. certainly contains information about your life and everything that you do, right? What happens when you back up your hard drive? You actually double your data. But have you increased your information at all? No, right? Obviously, a lot of you shake your head. No, right? You have not increased your information content at all, right? So the reason is because data actually have a lot of redundancy in them, right? So the most trivial kind of redundancy is duplication, right? Whether it's intentional or unintentional, whether you're retweeting someone or backing up your hard drive or sharing stuff that other people share, right? So these are duplicate. These are the most trivial kind of statistical redundancy, right? But data actually have a lot of other spatial temporal correlation and collinearity. Just to illustrate that point, right? If I take a picture of you all up here from the stage, right? This picture will look very different from the picture that somebody took from the back of the room, right? So, but these two pictures actually have a lot of statistical redundancy because there's something I can tell about the second picture from the first picture, right? So basically, data that are not statistically redundant is where the information lie, okay? So, so this is actually related to a concept called statistical independence in statistics. Now, if you know something, you could tell something about the second data set with the first data set, then those two data are not statistically independent, right? That means they have some redundancy in them. That make sense so far? It's a little bit deep. I hope that I can make this a little bit more easier later on, but these are foundational concepts I have to go through. Okay, so the second myth is that not all the information that you extract from data are actually insightful, okay? So to be insightful, you have to meet certain criteria. One is that it had to be interpretable. Second, it had to be relevant. And the third is that it had to be novel, right? So basically, the information that you don't already know, these are the new information. These are the insights. So for example, in Zest Finance, right, how many people would think that proper capitalization would predict people's default rate? You would never thought so, right? So therefore, when you find it, that's insightful. But next time they find it again, it's no longer insightful because they already know it, right? So now insights are very, very important, right? Insights can help you optimize your business process and as well as improve your customer experience and loyalty, as well as drive disruptions in market, build product that disrupt the market. Now, I want to talk a little bit about relevance because this is actually a fairly confusing topic. So relevance comes down to the understanding between signal and noise, okay? The relevant data is what we call signal. And the irrelevant data is what we call noise. The rest of it is called noise, okay? Now, the problem is that relevance is context-specific. It depends on who you're talking to. There's actually a famous quote from an astronomer says that one man's signal is another man's noise, right? Because what's relevant to me may not be relevant to you, okay? So it also, for example, like this wedge right here could be all the data and information that's relevant to me. This may be what's relevant to you. So obviously, we have some overlap because we're all interested in data, presumably, or driving change, right? So there's some overlap, right? But it also depends on when, right? So what's relevant to me today is the traffic coming here, right? But if I'm actually left and went back to San Francisco, then that information is no longer relevant to me, right? Depends on where, right? If I'm traveling to Japan, then obviously the restaurant there, the weather there is be relevant to me. But if I left and come back to San Francisco, then those will be irrelevant again, right? So now the key thing to realize is that what's relevant is actually encoded in the problem or the question that you're trying to address, okay? So what that means is that if you and I are trying to solve the same problem, the data and information that's relevant to you will be the same as those that are relevant to me. If you and I are trying to solve a different problem, those data will be different, right? What's relevant for you and what's relevant for me will be different, okay? Now, if you ever work with big data, how many of you actually work with big data? Don't be shy, okay? All right, few of you, right? You all probably discovered that big data is really noisy, right? Why do you think that is the case? Why do you think big data is so noisy? Well, to answer that question, let's try to understand like how people use data before they were big data. So how do people use data before they were big data? Usually you have a question, right? A problem that you're trying to address. And then you go out and collect the data to address those problems, right? So now, remember what I said about relevance, right? So these data is collected specifically to address those problems, right? So therefore, by definition, all the data are pretty much relevant, right? Now, what happens when you have big data? When you have big data, the point of having big data is that, big data technology had made capturing and storing a large amount of data really, really cheap, right? So what that allows you to do is that, you can actually collect the data before you have a question. Now, as a result, these data were collected not specific to any question or problem that you're trying to solve, right? So now, when you actually have a problem, when you run into a problem, say, OK, you have to look into your big data store and say, what data is actually relevant for me to address this problem? Then obviously, because these data is not collected specifically for this problem, so therefore a lot of it will be irrelevant, right? So what that means is that you actually have to have an extra step. You have to filter your big data in such a way that you remove all the irrelevant data or what you thought were irrelevant and keep what's remaining to address that problem that you're trying to solve. Make sense so far? It's very easy, right? Very, very easy, right? So, OK, so next. So one of the key questions for all of you is that, so where do you actually look in order to find insights? Where do you look in your big data? Do you find insights? OK, let's take a look at this again, right? So this is what we call this relevant data. These are the signal, right? And the rest is noise. So what you have to look is really, you have to look beyond what's relevant or what you thought were relevant. It's like what Zest Finance did, right? We all know that your credit card payment history, your income, is predictive of your default. But people wouldn't have thought of that, maybe if you fill out the application only uppercase or lowercase, proper capitalization would predict your default rate, right? So basically you have to look at so in that case, proper capitalization is what you thought were irrelevant, right? So you have to look just beyond that, right? So you have to look beyond that boundary of what's relevant. But you don't want to look too far away, right? You want to look at, just a little bit beyond that boundary of relevance, okay? So why, in the case of Zest Finance, right, they actually look just beyond that boundary because these are data about the person, about the loan applicant, right? Even though it may be what you thought were irrelevant, but they are actually data, behavioral data about how they apply for a loan. Now, okay, so the challenge here is, of course, if you look outside what's relevant, right, you may not find anything. But if you do find something, it's going to be insightful, right? So keep in mind that it's actually much easier to find new data that you don't know, new information that you don't already know, if you look beyond what's relevant, okay? If you know about it, then you would have been already in the this little sector, this wedge here in the relevant segment. Make sense? Okay. All right. So every time I talk to business about big data and data science, is that very often they don't actually want to have big data, right? They usually look like this, and so we know that we have a lot of big data today. We have plenty of data. We have no shortage of data, but we also know that the information that you can extract from those data are actually much smaller, and the insight that you could glean from those information are even tinier. What business really want today, so basically all the big data technology that you see operates down here at the infrastructure level, right? But what business really want today is the insights up here. What they want is they want to know whether a woman is pregnant or whether this person is going to default or not. That's what they want to know, right? They don't want the data. They don't want page after pages of application or page after pages of transaction. This is what they want, right? So this is what I call the big data gap. Today, most of the big data infrastructure operates down here. Now, how do you solve the big data gap? Well, how do you go from data to insights? How do business do anything? You pay people to do it, right? So basically, in the last year, actually, Harvard Business Review coined that data scientist is the sexiest job in the 21st century. Why? Because today, data scientist is the only way that business know how to bridge this gap, this big data gap. Okay? So now you may ask, well, what do data scientists actually do? Right? What do they actually do? Well, you can tell me if it's sexy or not later on. Okay? So first step is actually to get the data. Okay, first step is getting data. Getting data actually involves a lot of, I would say, janitorial work. Okay, you have to normalize for type range, do entity detection, do all kinds of these, like format the data to the proper kind of format so your computing algorithm can actually process it. So this is what I call data generating, right? Data cleaning. Okay, surprise or not, okay, 40% of a data scientist's job is data generating. Okay, it's actually important. You need to do that. Okay, because if you don't do that, you're not going to get to the next step. Okay, so getting the data, the raw data, is the first step. So getting the raw data, what is the raw data? Raw data is basically the text, the image, the sound, the video, and all that stuff, right? So raw data actually is not very good in any task, any problem that you're trying to address, right? So for example, you may actually understand what this sentence means. What the computer sees is this. These are the ASCII code that the computer actually sees. What is this image of? Can you tell me what this image of? Those who have seen this shouldn't answer. Right, a couple of you who've seen this last week. Who can tell me what this is? I don't think anyone could be able to tell me what this is. This is actually a letter A. Okay? This is what a computer sees when you type in a letter A, right? So now, let's say we have a task, right? Can the computer tell a bird from a plane, right? So imagine what a computer has to do to tell a bird from a plane, right? How do you do that? Basically, what you need to do is that you have to have a function, some kind of model, some kind of a algorithm, right? When you actually put in that picture of, say, a bird, right? It gives you a class 0, say that's a bird, right? When you put in that class, that picture, it actually tells you that it's a plane, right? So imagine you have what the computer must do to achieve that. What is the computer actually, what is this algorithm doing, right? It's actually looking at like a matrix of number like this, right? In fact, it's actually looking at 3 matrix of number because these are color pictures, right? There's the red, green, and blue channels, right? You have to look at 3 matrix of like numbers just like that and then be able to classify one as a bird and one as a plane. That's actually a very, very difficult job. That's very, very difficult, right? So if you actually look at any of the pixels, right? If you actually normalize for the probability that any pixel could be part of a plane or a bird, right? Basically, that is actually non-discriminative. The pixel information is non-discriminative, doesn't tell you anything, whether it's actually by looking at any single pixel, it won't tell you that the picture is a bird or plane, right? So what does that mean? That means actually pixels are actually pretty bad features. Okay, you may say, well, what does that actually mean? Well, I'm going to tell you what that means, okay? So raw data, right? So let's take a look at a little understanding of, try to understand what this feature actually means. Feature is basically any information you derive from the raw data and make explicit to the learning algorithm, the machine learning algorithm. Okay, so let's take a look at the case of Zest Finance again, okay? So Zest Finance, what do they have? What kind of data do they have? The raw data is basically, name, age, your ID information, your loan amount, your income, spending habits, and payment habit, blah, blah, blah. All these are you actually fill those out when you actually apply for a loan, right? Those are data they have. That's all they have, right? So they actually also scan your driver's license or your ID so they know, like, you're the right person, right? So basically, so if you actually look at name, right, and look at how informative it is to tell you whether someone's going to default. It's actually not very informative, right? People named Michael default just as much as people named Mark or Ralph or anybody else, right? You normalize it, of course, because there's probably a lot more Michael out there. So if you normalize it for the amount of Michael out there, they're pretty much flat. So name's actually not informative to tell you someone's default or not. In fact, if you actually look at the loan amount, people who borrow a lot default just as much like people who borrow very little, right? And in fact, rich people default just as poor people, okay? So in fact, if you actually look at, the strange thing is if you actually look at age, right? When you get to really, really old age, people actually default slightly more. Why do you think that's the case? Because people die in really old age, Yeah, so, okay, all right. So in fact, if you actually look at any raw data, any of these fields, right? They are not very informative. They don't tell you whether someone's going to default or not, okay? So what do you do, right? During the underwriting process, what are you actually doing? You compute something else, right? You use these raw data and you compute, for example, the loan-to-income ratio, the debt-to-income ratio, right? These are the feature that we're talking about. These are information that is much, much more predictive of your default probability, right? Much more than, right? It's not your loan income that matters. It's the loan to income ratio that matters, right? If you borrow a lot, but you have a lot of money, who cares, right? So you may have to ask yourself, like, what information can I extract from these data, right? From the application form, right? Can you extract, like, their frequency of late payment? Yeah, if you actually tell me your payment habit, I could extract your late, payment frequency, right? And you can also look at the income or spend volatility. That data is actually in there as well. If you actually look at your historical, like, income or spending habit, right? So in that case, these features, if you actually look at these features, they become much, much more informative, right? People actually, if any one of these features would be much, much more informative than this raw data, which is kind of flat, doesn't tell you anything, right? Does that make sense so far? So far, so good? OK. So let me ask you, is the use of proper capitalization, is this information in the application form? Nowhere in the application form did they ever ask applicant, did you fill out the form in all uppercase or all lowercase? Nowhere did they ask that, right? No application ever asked for that. But that information is actually in this data. It requires some processing to extract the information, right? To make that information explicit. So how about the number of times you save before you submit the application form? Or the average time between saving, right? If you actually save it and you wait a week and come back and trying to fill out the application. So all these are information that's actually available in the raw data, right? Because you have a timestamp every time people save something, right? So how about the day and time of the week when they actually fill the application? Sure. Because if I know the day and the timestamp, I could figure out what the day of the week is, right? Right? So remember, they also scan your ID, and then so basically they also know, like, your hair color, your eye color. They can OCR all the information in your ID, right? They can actually know your weight and your height as well. So these are all information that I could extract from this application, in this application form, right? So strangely, that's finance. I find that, like, if you're taller, okay, if your height is taller, then you're actually less likely to default. Do you believe that? Now, you may actually speculate. You may speculate for all kinds of things, right? For example, like for people who don't fill out the application in proper capitalization, okay, these people are probably less careful. So they probably are not going to have detail-oriented jobs, so they have lower-paying jobs, so they're less likely to repay their loan. Right? You can speculate, but you can also speculate that top people appear more confident. They're likely to have more high-paying job. They be a better salesman, right? So they're much more likely to actually pay back their loan, right? You can speculate all you want, but the bottom line is that they actually put this feature, height. Remember, they find like thousands of these features, right? When they put height into their underwriting model, it did not improve their loan default rate at all. So what that means is that this is actually not causal. Okay, it's just correlation. Okay, so so let me ask you another one. So how about where did they fill the application form? The location and where they actually fill this application form. Is that information in the application data? Come on. Yeah, right? Because you probably have an IP address. From the IP address, therefore, you can infer the location, right? How about this? How about when it's raining or sunny when you're actually filling that application form? Is that information in here? It's actually not in here, right? But it's actually derivable, right? Because if I know where they actually fill it out and when they fill it out, I could look up the weather data in order and figure out whether it's actually sunny or raining when they actually fill the application form, right? So keep in mind that these information don't even have to be in the application data itself. It just has to be derivable, right? So basically, feature engineering, there's a step called feature engineering. Feature engineering is all about the process of making implicit information available, make them explicit, right? So these are all the implicit information that's available in this raw data. I'm making them explicit, right, to my machine learning algorithm. That's called feature engineering, right? So that step happens here between the raw data and then the feature, right? When you engineer a feature, you extract the information, right? The information is actually now available for your learning algorithm. Okay. Now, if you have good features, informative features, the problem becomes really, really simple, okay? So what are some good features of, say, a bird and a plane? A bird, a good feature would be that they have a beak, they have an eye, they have feet, and they have feathers, right? A plane, a good feature for a plane is that they have stabilizer, they have engines, they have windows, right? Now, if you have these good features, the problem becomes really, really simple to tell whether a picture is a plane or bird, right? For example, let's take a look at two features, right, for a bird and a plane, okay? So this is an axis that I say is the probability of occurrence of a beak, and this is the occurrence of a stabilizer. So if you actually look at these pictures of birds, right, these pictures, you can all see the beak very clearly, right? This one is actually looking at you, so you probably can't see the beak very well, so the probability of a beak is really low, but none of these picture have a stabilizer, so the probability of stabilizer is all pretty low, right? Kind of like down the left side, but right here, okay? Now, what about a plane? What about stabilizer? For this one, and I could clearly see the stabilizer, right? For these two, I could barely see it because they're kind of flying towards me, right? The stabilizer is it's very hard to see right here and here, right? So those probably have a lower probability, but they don't have beak, right? These planes don't have beak, right? But this one sort of have a nose that's really, really sharp. It looks kind of like a beak, right? So so probability of having a beak is pretty high, right? But I could also see a stabilizer here, so its probability of stabilizer is pretty high. So now, if you actually plot this on this plane, basically, it becomes really easy to classify whether you have a picture of a bird or a plane, right? Basically, you just do very simple statistic. Even if you use a linear classifier, you could classify whether it's a plane or bird very well, okay? So basically, data science is actually 20% handcrafting of these features, all right? So basically, you go from raw data to feature to a model, right? So today, the people who are responsible for getting the raw data, they're basically computer scientists, right? So this is a lot of plumbing, cleaning, and janitoring. And to extract informative features that are informative, useful, right, and discriminant for your task, there's a lot of handcrafting. And that actually requires a lot of domain expertise, all right? Now, to build a model, the rest of it is actually pretty simple. Once you actually extract useful, informative feature, the math and statistics problem become very easy, okay? Now, today, most data scientists does a pretty good job in getting the raw data. What they don't do very well is this, okay? They don't actually learn enough of your domain knowledge to design and create and engineer informative features. They do a decent job, I got a sideways thumb, right, on modeling, okay? So what they don't do often enough today, or not enough, is validating their data, the model, okay? They will come up with a model, and then they will test it a couple of times, and if it works, then they're happy, okay? In academic, people do a lot more rigorous job on validating their model. Now, if you actually Google around and see what data scientists do, there's one more thing that they do, and that is communication, okay? You have to essentially explain the data science to the management, to the senior executive, so they know what it means to their business, okay? So this is actually a lot of data visualization, storytelling, and translating data to the business owner, right? So this also requires a lot of domain expertise. And today, most data scientists also do a half-decent job on that, okay? They are actually doing much better today because it's necessary to actually stay in the company long enough to make any difference. So if you actually put these three things together, you've probably seen this before. Data science is really just an intersection of these three things, okay? So domain expertise, computer science, math, and statistics. So early on, when data science was just a new field, right? Data science is really the intersection of those three things. So, but after Harvard Business Review, basically says that data scientist is the sexiest job in 21st century. Everybody who works with any data is going to call themselves data scientists because they automatically get a salary increase, right? The problem is that today, many managers who hire data scientists don't know the difference, right? So today, if you actually look at this thing, data scientists today is more like the union of these three things. If you actually work in any area of data science, you are considered a data scientist, okay? Now, so data science actually, what I see is actually consists of these three layers. The first is the infrastructure layer, and those are the people who are actually responsible for the janitoring and plumbing, right? And then you have the algorithm layer, and then you actually have the decision science layer who actually help the decision maker make better decisions. So what makes a good data science problem? It's really the intersection of these three things again, right? So is that the first is that they have to be addressable immediately by accessible big data. If you have to collect the data, forget it. Right? It's too late, right? It takes too long, right? The second is that it has to have high business impact. And the third is that like you have to actually be motivating to the data scientists, right? So today, very often I go to a company and talk to people. They say, data scientists, they're doing this magic thing I don't really understand, and they just shove them in the corner, okay? And basically any kind of data problem, they just shove it to the data scientist. Even like writing like simple queries, right? They give it to the data scientist. You should not ask your data scientists to do such a rudimentary job, right? It is important that they need to do it, but you should not just give them any data problem, right? The data problem should be motivating to them as well. Okay, so now, here, like I said, it's important to be immediately accessible, right? It's data that you can access right now. Okay, so now let's kind of step back and take a look at from an industry view. So from an industry's perspective, data science sort of evolved, sort of exists, for a long time. It just hasn't been called data sciences. Previously, it's actually called analytics, okay? So let's take a look at how analytics evolve, right? And I'm going to actually use a toy example to illustrate the evolution of business analytics. So first is that let's actually use this is actually a stock data, okay? So all of you are familiar with stock data, right? So first is that you collect all the data, right? You plot them, you're on the graph. And you can actually compute a lot of like statistics on them, right? The indicators and trend lines and all that stuff, right? So all of these are what I call descriptive analytics. All you're trying to do is summarize the data that already exists, right, in some way, right? Now, and then after a while, you're going to see, okay, that's interesting. I actually could build a model, right? Once you build a model that describes this data, the advantage of having a model is that you can actually extrapolate to regions where you don't have the data yet, okay? Here, this is now, right? So this is the place where I don't have data yet because it's in the future, right? It don't exist yet, right? So once you have a model, you can extrapolate beyond the region where you have the data. Now, of course, you basically move into what we call the predictive analytics, right? Of course, when you have predictive analytics, you still need to continue to do your, descriptive analytics, right? You still compute like these indicators and trend lines, this stuff. But after a while, you could actually move from the predictive regime into what we call the prescriptive regime. Now, your system can start to recommend you to take certain action. For example, this is a good time to buy, right? Now you move into what we call the prescriptive analytics. Like I said, once you have prescriptive analytics, you still need to do your predictive and also descriptive analytics, right? And your prescriptive analytics may be really, really smart. They can actually tell you things such as, okay, this is a good time to buy, but don't sell everything here. Sell 50% here and sell another 50% there, right? It's telling you stuff to do, what to do, okay? So I want to say a couple of things about predictive analytics and prescriptive analytics, because a lot of people have a lot of misconceptions about them. So predictive analytics is about estimating quantity that you don't know, okay? So I basically already illustrated a very simple example of a trend line using, right? So this is a trend line. Temporal prediction is basically a trend line, okay? So there, what you're trying to do is that you're trying to take the historical data that you have, right? And then this is the present time, and you build a model, and then you're basically trying to predict your future data. Now, future data actually doesn't exist, okay? It's actually a future prediction. Right? You can't go and measure tomorrow's data and come back and tell you and report it. Physics don't allow you to do that yet. Okay, now, general predictive analytics are not limited to time domain. Okay, let me illustrate what that means. There, what you're trying to do is basically you're trying to take the data that you have, put it into a model so that you estimate the data that you don't have. That is actually a much more powerful use case of predictive analytics. Using data that you have to estimate data that you don't have. In the case of temporal prediction, future data are simply the data that you you don't have, right? And in fact, you can never have future data, right? So that's only temporal prediction is only a very specific use case of predictive analytics. So let's take a look at some other examples of predictive analytics. Let's look at Target, right? And that's finance. Basically, the data that they the model that they're trying to build for Target is a pregnancy classifier, right? And the data that they have is basically purchase history, right? Item, quantity, price, payment method, when, where, blah, 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 all that stuff, right? And then when they put it into this classifier, it tells you whether this person is pregnant or not. That's finance, right? The model that they're trying to build is basically a default predictor. And the data that they have is basically, these application fields, right? This stuff that they ask for when you apply for a loan, right? When you put it into this default predictor, it gives you a probability of default. Okay? Now let's take a look at a couple more examples in social media, right? So in social media, we can actually score people's influence, right? Social media, a lot of people are on social media. How do I know who is influential, right? In the media business, people always want to engage with influential bloggers and video creators and so on and so forth, right? So it's very important to actually score people's influence. But people actually don't go out and measure people's influence, right? The data that we have is basically people's social media interactivity, is who you interacted with, who you like, who you retweeted, who you share, right? So these are the social media data that we have, right? And then the model is this influence algorithm. When you put basically these data into this algorithm, it pops out an influence score. Okay, it tells you a score, how influential this person is, right? So there's a company, Cloud, that actually does that for their business, right? And in fact, we actually acquired them, so they're part of us now. So that's why you see them here, okay? So there's another example, sentiment classification. Anybody here know about sentiment analysis? I'm sure a lot of you know about it. You guys in the media business, right? Okay. So sentiment analysis, the model that you're trying to build is sentiment classifier. But what is the data that you have? The data that you have is basically text data, any text data, whether it's a tweet, a blog, or article that you write, or article that you publish, right? Email, SMS, whatever, right? These are the text data that you have access to. What you don't have is what's people's mind thinking. Are they having a positive sentiment about something or negative sentiment about something, right? So when you actually put that into this sentiment classifier, it actually tells you whether this person is thinking positively, negatively, or neutral about certain things. Okay? So that's what sentiment analysis. So these are essentially, I would say, a much more powerful use case of predictive analytics. It's not about predicting the future, right? Once you have the sentiment classifier, you could put Hamlet in there, right? And see when he's happy or sad, right? Most likely he's going to be sad all the time, right? So, or you could put the Bible in there, right? You could say when Moses is happy or angry or whatever. You can see, right? You don't have to predict things in the future, right? You can estimate data that you don't have. That's actually a much more powerful use case of predictive analytics. Okay, so prescriptive analytics. So prescriptive analytics. The simplest prescriptive analytics is a GPS. I want you to compare that, to a trend line, which is the simplest predictive analytics, right? So in the GPS, what do? You tell me where you want to go, and then basically I prescribe you a route to get there, right? So prescriptive analytics is all about optimizing something, okay? What are they doing when they're actually prescribing you this route? They're optimizing for the shortest distance, right? You can optimize for different things too. For example, if you optimize for the fewest turn, right, or the fastest route, it's going to prescribe you a different route. Okay? So now, the simplest prescriptive analytics is GPS, right? Compare that to the simplest predictive analytic, which is a trend line. What did I say about a trend line? Right? The general predictive analytics is not limited in time domain, right? They're not limited in time domain. For example, in influence and sentiment, which I'd already told you about. Likewise, the general prescriptive analytics are not limited to the geospatial domain. You can actually prescribe, things in business, right? For example, I want to increase my sales by 20%. That's where you want to get to, right? the prescriptive analytics engine may tell you, so, okay, you have to hire 10 more salespeople and then hire 5 more engineers to build a really cool product and then have those people sell it, right? These are the turns that they're prescribing you to do, okay? So that's the general prescriptive analytics, okay? It's about optimizing something. So to illustrate the difference between predictive and prescriptive analytics, let's take a look at some of the examples that we actually solve at Lithium. So Lithium, through the acquisition of cloud, we actually have 750 million, actually close to 800 million user profile now, okay? That's a lot of people. So these are the data that we have. So we can do infinite amount of descriptive analytics. Let's take a look at the more interesting stuff, predictive and prescriptive, okay? So for example, we can actually infer who's influential, right? These are data that we don't have, and we want to know, right? We can also infer the topic of interest. What are they interested in, right? So that's, we actually published this, so if you want this paper, let me know, I could send it to you. And we also can infer the topic of expertise, right? These are using data that we have to estimate data that we don't have but would like to know, okay? So now, not only do we know you're influential, we also know what your interest is, your expertise is, okay? Imagine how powerful that is, right? So we also have prescriptive analytics, right? We also show you when's the best time to publish on social media. So media professions also like to use this feature a lot, right? So out of all the time that you can publish in a day, right? These are the best time to publish, okay? It's just like a GPS. You could go to the destination in many, many different ways. Out of all the different ways that you could get to the destination you want to go, this is the route that will either optimize for the shortest distance, or optimize for the fewest turn, or optimize for the fastest route, right? So out of all the time that you could post, these are the time that you should post in order to optimize your reach or whatever, right? So whatever's optimizing. So we also publish that. Now, these user profile also generate a lot of user-generated content. So we could also do predictive analytics on them, right? So one of them we actually are experimenting with actually actionability. So it's very easy for us to understand, humans, to understand what kind of message is actually actionable and what message is actually not actionable. But it's actually very difficult for you to tell a machine what is actionable and what's not actionable, right? So we actually use machine learning methodology to kind of do this. Another one that we do is actually prescriptive analytics is similar content. Recommendation engine is actually a prescriptive analytics. What are they optimizing? They're optimizing for similarity in the content to your topic of interest. That's what they're optimizing, right? So if you look at it that way, and another one that we actually, so these two are actually not soft. They're actually, that's why they're light orange, right? So intent, can we infer people's intent, right? One of the most important intent for marketer is, are they going to buy or not? This is the buying intent, right? Wouldn't that be really powerful to understand from social media, from what they talk about, to understand whether they have intention to buy? That would be golden, isn't it, right? Unfortunately, this is actually still work in progress. What we find is that people's intent to buy is actually very different. It's actually context dependent as well. Whether your intent to buy a clicker, or intend to buy a bottle of wine, or intend to buy a car or a house, it's very different, okay? The behavior trait, the behavior signal is very different. Okay, now you know the progression of essentially the history of business analytics. They all go from descriptive to predictive to prescriptive, right? Now, very often when you actually want to create disruption in the business world, it's never about showing you a bunch of data, right? It's usually about building a new product that addresses some needs of the consumer, right? So each one of these products actually have its own challenge, right? If your product involves using descriptive analytics, right? Descriptive analytics just summarizes data. So all you need is data. You compute a bunch of summary statistics on this data. So what's so hard about descriptive analytics? The reason it's so hard is because it's highly context specific, right? Most people know data about that they generated themselves. I know how much data I generated and how many messages I posted, right? I kind of know. I kind of have an idea. Who's my friend? I know that, right? So in order to make this actually useful, you have to catch me at the right moment, not only present me with the right data, but at the right time as well. That's not easy, okay? So Google did this really well. So Google Now, anybody actually use Google Now? Good. They're very good at capturing the right context, right? They show you just the information just when you need it. Not before, not after, right? So that's what's difficult about prescriptive analytics, right? How about predictive analytics? You certainly need lots of data, right? But here, the challenge is that you have to build a model and you have to validate that model. Make sure that model is actually predictive. Now, the third, prescriptive analytics, that is, so certainly you still need a lot of data. You still need to build a model, validate your model. But the most challenging aspects of building a prescriptive analytics product comes from the fact that they have to be actionable, okay? This is actually a very big challenge. It actually comes down from specifying all the constraints, right? So for example, if I say, what's the shortest path to get me from this side of the building to this side of the building, right? If you don't specify all the constraints, it's going to say drive through the building, right? But that's an action that you cannot take. Your car cannot drive through this hotel, right? So you have to specify the constraint. Basically, you have to say that you have to stay on the road, right? So, and then you have to make the turns and so on and so forth, right? You cannot, go through like a lake or river or something like that, right? So these are constraints that you have to specify, right? So likewise in business, right? If you actually have a prescriptive analytics system that tells you, I want to get to 20% increase in sales. That's what I want to go to. But then it tells you to hire 10 more sales and 5 engineers. What if you don't have that resource, right? You did not constrain this optimization enough, right? So that's actually a big challenge. Another challenge is that keep in mind that all prescriptive analytics is actionable, right? If it's not actionable, it's not prescriptive, okay? So another challenge is that you have to have a real-time feedback. So this is also very challenging. The real-time feedback is that it has to tell you where you are, right? If I'm trying to get to 20% increase in sales, I need to know my sales every minute, every hour, right? This is in the GPS situation, right? The real-time feedback is essentially where you are, right? That blue dot that shows you where you are. Imagine how good a GPS will be if you don't know where you are. It's not going to be very helpful, right? So basically, most of the traditional business intelligence systems have lots and lots of descriptive analytics. Some sophisticated ones have predictive analytics. Actually, most of them probably have it now. Some of the most sophisticated business intelligence systems have prescriptive analytics as well. So you can say, well, what's next? What comes next, right? So to understand that is basically we have to understand that business intelligence systems traditionally serve a very passive role, okay? What that means is that at the end of the day, humans still have to make the decision on what to do, right? It may recommend you to buy that stock or sell this stock at a certain time, but you as a human still have to decide whether you want to buy or sell. You still have control, right? Okay, so what comes next is that can we actually get to artificial intelligence, going from BI to AI, right? What that means is that basically you have to go from data to decision to action all in one path, right? Normally, humans are the ones who make the decision, going and then take the action. Normally, this is what we do, right? But if you have AI, artificial intelligence, your system can be intelligent enough that it could be built into part of the process. It could be automated. And there are many, many examples of these today already, right? For example, there's algorithmic trading that will trade on your behalf. You just have to tell me your risk profile. Your risk profile is basically the constraint, right? I cannot violate that, right? So, and it's optimizing for the action that you need to take to optimize your return, right? So that's basically algorithmic trading. There's actually a lot of robo-advisors out there. Anybody actually use robo-advisor? I actually do, right? So I don't have time to actually manage my own stock. So anyway, so they actually make the trade for you, right? You just tell me your risk profile, and then instead of telling you when to buy and when to sell, they just buy and sell for you, okay? So likewise, in the lending space, there's actually automated loan origination. If you have all the requirements, then it's actually going to pre-approve you, right? What's more amazing is that today, we even have the self-driving car from Google, right? Instead of prescribing you turn left, turn right, and so on and so forth. It just makes the turn for you. Isn't that amazing? Okay, so let's review, all right? So to create disruption in the business, in the industry, right, you need to start with data, right? Usually it's a big data, right? And then you need to extract information from those data. And this comes down to feature engineering, right? You learn about that. And from that, you can actually build models and visualizations, and then that will actually give you some insights, right? The insights, basically now you split into two tracks, right? The management track, the senior management track, basically now you have to use this insight to make good decisions and take good actions. And then on the other hand, to disrupt the market, it's not enough to make good decisions and take good action. You have to build new product, okay? So this actually comes down to going from descriptive to predictive to prescriptive, going from BI to AI, right? Removing humans in the loop, right? One example is this, is basically Uber, right? They are a data product, right? But it's not about showing you data, it's actually trying to solve a problem that humans have, right? Using data to solve a problem that humans have, giving them a better experience, right? It's not showing you data that you may or know or may not know, okay? So if you have all this two track kind of communicating back and forth in very high frequency, then you may actually have a chance for disrupting the market. So with that, I am done. So thank you for your time. And if you want to dig deeper into some of the other stuff that I do, I have published 2 books on the science of social. And that's it. Thank you. Cheers.
Michael, I'm lucky you take a sip from your glass because we have a tremendous misunderstanding. We would have had some wine instead of you on stage. But thanks for the keynote. Maybe I understand something right. I'm just testing you. Is it like you as a data scientist, are taking all my noise and telling me what I'm going to decide next?
So I guess I don't quite understand the question. I mean, when you think about your noise, right, you have to talk about what problem are you trying to address, right? Start with the problem first, right? Before you know the problem that you're trying to address, you don't know what's relevant and what's not relevant, right? Remember, relevance is determined by the problem that you're trying to solve or the question that you're trying to address, right?
I'll give you another one. 61 years ago, I was born at 10 to 10. It's time in the morning. It was sunshine, and I got stuck on the way out. What does it mean for my career?
I don't know.
No, I'm just telling you that because I wasn't quite sure if I get that right. What is causality? Mm-hmm. What is correlation? And is correlation not just a coincidence of something? And how do you get from correlation towards that very interesting causality? Yeah.
So that's actually quite a challenging problem. So everybody wants to know causality, right? You want to know something caused something, right? So if I says, let me give you an example. So if you see that Facebook likes goes up and your sales goes up, or your media consumption goes up, what does that actually mean? What does that mean? Nobody know what that means? It means that they're correlated, right? They're correlated, right? Facebook goes up and your media consumption goes up, right? So now, let's use a product, right? If Facebook goes up, sales goes up, right? That means they're correlated. Now, this could mean many things, right? It could be that, I find your Facebook fan page and I read about your product and I really like it and I like it on Facebook, and then I actually go and buy your product, right? So that's the causal path, right? By increasing the Facebook likes, I can actually predict my sales forecast. I can actually forecast my sales of a product. But you could also, what we call another path, another mechanism is what we call the anti-causal, right? That means people can actually buy the product and use it and find out that that's actually really cool and they actually go to Facebook and like it, right? So this is a reverse causal, what we call anti-causal, right? So this path is not less useful for you because you can't affect it, right? Because they already bought the product, right? Whether they go, whether you increase the Facebook like or not, it's actually not going to drive sales, right? Or it could even mean a third thing, right? It could mean like there could be a marketing promotion, right? Come to Facebook, like our product, and you get like 10% discount on the product, right? So, that's a common cause, right? So when you have something, a marketing promotion causing likes on Facebook and sales of your product, right? So these, with three things, will all lead to the same kind of data where you see a correlation between Facebook like and sales, right? Now, to distinguish which one is causal, the simplest way is just to experiment with it, right? You could turn off your Facebook and see if your sales decrease, right? Or if it doesn't, then you know that it's not causal, right? If it does, then you know it's causal, right?
Trial and error, that's the
experimentation, right?
Experimentation.
Yeah.
You said data scientists is the most sexiest job, but tell us, when you as a data scientist go into to companies, legacy companies, what is your challenge normally? Are they feeling like, oh, this is the most sexiest guy coming in? Probably not.
No. So there's many challenges. So usually big companies initially face the biggest challenge in the infrastructure layer. So remember those three layers I said, bottom here is the infrastructure and the algorithm and decision science, right?
The cleaning up and all that stuff. Huh?
So most big companies today have the biggest, initially, when they actually first embark on the big data journey, the biggest challenge happens to be in the infrastructure, right? So they actually hire a lot of computer scientists, build out the infrastructure, and then the next challenge is basically the decision science. The algorithm, right? They don't know what to look for, right? The biggest challenge, biggest question that I often get asked is like, I have all this data, what do I do with it, right? They don't have the expertise to kind of extract the information, essentially the features, okay? The informative features from their big data, right? So that is actually
so you help them to find the right questions for the algorithm.
Yeah, sometimes.
Sometimes.
Yes.
Even that. Hey guys, it's yours. Comment, questions. I think there's a lot to ask. It's not just me. Who is going to take the first question?
I'm a little bit tipsy, so I could be very creative.
Yeah, I'm with you. Lars, please. Thanks. Björn, thanks.
Hi, Michael. My name is Björn. Nice to meet you.
Björn, very nice meeting you.
It's good to have you on stage because I'm a big fan of this idea to have self-driving cars and stuff. But I'm always wondering how big data or how the car can decide when it's driving a street. On the right is like an 80 years old man, and on the left there's a mama with a baby carrier. So when does the data decide which one to actually kill?
Yeah, so, okay, I would pose the same problem to a human, right? How would a human make that choice? If you had no choice, if I was a smart car, self-driving car, I would just stop killing neither, right? I mean, so that's a normal thing that a human would do too, right? That would be even a challenging problem, even for a human, right? If I were given to you as a human, as a driver, right? If I have to kill one, if I don't have enough time to stop, right? Do I kill one or the other, right? Even us human would not be able to make that decision rationally either, right?
We have another question here.
Yeah, I think you have to do it, but I mean, I think that the better solution is that to early detect the problem, right? You detect that, okay, there's a mama there, an 80-year-old there, and then I should just slow down, right? So I could avoid killing either of them. Yeah. Question back.
Thank you very much for your presentation. It was very interesting. I'm curious to understand a little bit more about your thinking in terms of the politics of data. Because
politics?
we are in Europe right now where the concept of data privacy is very different than where you're from in the United States, which is an open system and there's not a relationship between the data and the person. Our data in the US is owned by the companies. The notion here in Europe is that the data is an extension of the self. In China, there is no concept in personal privacy and data, so it varies from country to country.
That's right.
What you're talking about is very much in an American context. I'm curious to hear what your experiences are in other countries, in other parts of the world, where the notion of privacy and data are very linked.
Yes, so that is a challenge, right? No doubt. So I think it's a matter of time that people will have to slowly accept that trend, because ultimately, data, using data, you can actually provide much better customer experience and actually help them solve many, many problems that they in their daily life. Okay, so if you are willing to give up those benefits, sure, keep your privacy, right? I mean, so one of the example that I always like to give is like personalization, right? If I could actually, how can I personalize a product or a recommendation for you if you don't give me any data about yourself, right? So that's inherent trade-off that you have to make, right? At some point, I think that the consumer will have to decide what's important for them. Is my privacy really that important for me? Or is that for me to essentially know that I'm going to be late or for a train or a plane or something, right? Then I better to keep my data so that actually could help me solve my problem, right? So let me ask you one more example, right? How many people here use iPhone? A lot of you use iPhone, right? How many people actually enable the Find My iPhone app? A lot of you also do, right? Why? You're giving up your very private data about where you are, right? But what's the trade-off? The trade-off is that if you lose your phone, if you don't have that app activated, good luck finding it. You're going to lose all your photo and all this stuff, and you could be hacked by other people, right? And you could even lose even more data, right? So that's a trade-off you have to make, or a consumer have to make.
Michael, we have another question here from Andres.
I'm not a
Andres,
psychologist, but as far as I know, psychology has a lot to do with statistics and collecting data. Do you think sometime soon big data will replace psychologists?
I don't think so.
Thank you.
Yeah.
Why not?
Because there's collecting of data. So when we talk about collecting data and analyzing data, it comes down to understanding behavior and also predicting behavior. But like for example, let me use descriptive analytics, right? Descriptive analytics is actually very, very good at telling you what happened. But it rarely tells you why things happen, right? So there you do need some psychology to understand why people behave the way they do, right? Having the data just tell you what happened. Okay, I like to drink wine on the same, not just wine, but I mean, it just happened that, Mark saw me drinking wine last week when I was giving a keynote speaker at a different conference, right? So that's data, right? But why do I do that? There's no data that tells you. I mean, if you actually record this video, right, telling you what happened, if you could actually measure my tracking of, what I drink and all this stuff, all these biosensors, right? You can actually know that I drink, and every time very often when I speak, I do drink a little bit, because people know about this about me. But it never tells you why, right? To understand why, you have to dig a little deeper, right? To understand like the psychology of me, right? Do I want to? Is that because I just feel more relaxed, or like I said, sometimes it actually makes me more creative in answering questions from you guys.
Kante has another question here, Michael.
Yeah, hi. Really great to hear you.
Thank you.
And amazing insights. I think the journey you mentioned about how this entire big data thing is evolving is really amazing. So my question to you is, you talked about the fact that if I put an offer on Facebook, and if
an offer?
And an offer on, like if I like Facebook, like a page, and then I get 10% off, so I can see an increase in sales.
Yes.
Right? So I'm like a small businessman and who sees that, wow, this is great. Now, on the other hand, Facebook has evolved to the highest level of AI, whereby they know that this is just a start to get me in, and then with their algorithms, they will actually make you spend a lot more and more and more, and then you'll be in a situation like Coca-Cola where you spend $16 million, and then when you do a post, you get like 14 shares about it. So I'm just trying to understand that, how does that work for a small organization? Because you're enticing on one hand, like as media companies, I mean, we all spent a lot on becoming big on Facebook. And then now we know that it reaches 2%, 1.5%. So, I mean, those guys are way ahead of the game in terms of, the architecture you described, like how you start with like just predictive, then you get to AI and stuff. So as a data scientist, then what would you say? Because, I mean, you're big on social media, you understand these things.
So I would say that, what you described has already happened. Okay, organic reach on Facebook is actually down the drain, right? And you have to pay a lot of money for this pay reach, right? So it's what I would say that it's important to take that data, take that hub, this consumer engagement hub back into your own hand. Okay, you need to actually own your consumer, not let Facebook own your consumer, your customers. Like for example, a lot of you here are in media. You should engage with your readers yourself, not through Facebook. Facebook is a very good acquisition engine. Okay, it's a very good it's very good for spreading the news and propagate them through their viral network, right? But you need to engage them personally. Okay, so you keep their data and you know who they are, and that's what's most valuable in the long run.
Michael, we take a last question there.
Okay. Yes.
Yes, I have a little lighter question.
Yep.
Would you say that things like, for example, Chinese calendar or Chinese horoscope or Kabbalah are the early examples of big data usage?
I didn't quite understand the question. So,
if in case of Chinese calendar,
Chinese calendar
or Chinese horoscope, okay?
Okay.
You predict something happens with the person in the future. The same.
I see.
Kabbalah. Do you think that would you call them early example?
I would just say that they're simple observation statistics, right? If you see that this person, with these kind of physical trait or born in a certain day in the month, they have these kind of tendency, you're just summarizing data, right? Basically, you say, I've seen like 1,000 people whenever this happened, this always happened. I mean, in Chinese, and probably document a lot of those in their history, so they actually could make a fair judgment of what it's going to be like, even though it's not perfect. I would say that that's a very rudimentary way of predicting what you're going to do.
Michael, it was great having you on floor today. Thanks a lot.
Thank you. Thank you very much. Thank you.
You take the wine with you, huh?
Okay. So I actually have to run off to give a lecture in St. Gallen University. But I have two colleagues here, Andreas and Ivano. They're here. So if there's any question that you feel that I did not address properly or have enough time to address you, please let them know, and I'll be happy to address any question you may have. Thank you very much.
Thank you.